In this video, I want to just make sure you understand some terminology. And I say this as a bit of topology because in a upper level math class called topology, we look at these concepts and much more based on these things in a very general setting. Right? I want to look at sets, and I want to look at interior points and exterior points and boundary points, open sets, and closed sets. And really, I'm doing this here because I want to talk about essentially one-sided limits on functions of several variables. In Calc 1, when we talk about limits, we have limits as you approach from the left or limits as you approach from the right. Well, I'm going to want to say limits as I approach the edge of my region, whatever that means. And so we got to make sure we understand what that means. Right? So suppose I've got a set. So I have a curve drawn here, but I'm thinking about all the curve and the points inside the curve here. Right? That's the set I'm thinking about, set of points. And I would call a point an interior point. That, like this point right here, is an interior point if there is a disk of radius bigger than 0 that is completely contained inside the set that contains the point. So I need a disk that contains this point, but the disk is inside the set. If I can find such a disk, then the point that I started with is an interior point. Notice I can be way out in the middle here and get a big disk, or I could get a little disk, it doesn't matter, as long as I find one. If I'm up close to the edge, I might need to find a really little disk that'll contain that point and be still contained inside of the set. If I can find such a thing, then that's an interior point. Right? An exterior point would be a point where you can find a disk that contains this point that no point in the disk is in the set that you're talking about. That would be an exterior point. Again, I don't care how big this is as long as it's got radius bigger than 0. I don't want to just call a single point a disk. I want it bigger than that. That's an exterior point. A boundary point is then one that's not interior or exterior. So the boundary point would be a point where every disk that contains that point contains both points in the set and out of the set. You can say, well, I look at a point here and say, oh, look at that disk contains stuff inside and outside. Does that make that a boundary point? No, because although you found one that has interior and exterior points, if I take it small enough, then I have only interior points in that disk, and that's an interior point. Boundary points, every disk you draw around it, whether it's a big one or a small one, it'll contain points inside and outside of your set. That's what I call a boundary point. Now, an open set is a set that does not contain any of its boundary points. So that would be, if I drew this thing here, I'd say take the whole interior, but don't take any of the points on the curve. Usually when I draw such a set, I would draw the boundary as a dotted line to indicate that it's not part of the set. I want all the stuff inside, but not on. Right? That would be what's called an open set. It contains no boundary points. Likewise, a closed set is a set that contains all of its boundary points. So I think the way I drew this original one would be a closed set because it has all of the boundary points included. Now, when you actually take a topology class, the notion of an interior point actually is linked to an open set, where when they talk about these disks, they would be open disks. And when you say open disk, that would exclude a disk of radius 0. Because a disk of radius 0 isn't open. It contains only one point. And that one point, well, if it's in the set and you draw a disk around it, you'd have that point and you'd have points outside, and so that wouldn't be interior. Anyway, so to say you have an interior point is to say that there's an open disk around it that's contained completely in the set. We can get away with not saying open by just saying make sure that the radius is bigger than 0. Because as soon as you have a disk with radius bigger than 0, I can draw a little slightly smaller open disk with radius bigger than 0. So it doesn't matter at that point whether it's open or closed. But in general, when we talk topology, they will describe interior and exterior points with open sets. And if there's an open set containing that point inside, then it's an interior point. Now, why are we doing this? We're doing this because I want to look at one-sided limits. For instance, consider this limit. The limit as xy goes to 2, 0 of the square root of 4 minus x squared minus y squared. Well, that's the point right here, 2, 0. That function, the square root of 4 minus x squared minus y squared, the domain of that function is everything inside and on the circle of radius 2. X squared plus y squared equals 4. Outside of that, you're trying to take the square root of a negative number, and this function doesn't exist. So the notion of taking the limit as defined as if for each epsilon bigger than 0 there exists a delta, and delta draws a little circle around the point that you're approaching and says every single xy point in that circle needs to give you a function value that's close enough to what you think the limit is. Well, that's not going to happen because some of the points are not even in the domain of the function, and so you can't take the function value of those points. So we have to give a special definition for what do you mean by limit on a boundary point, because I can't squeeze in close enough so that every xy is going to give me the function value I want. Some of the function values aren't going to exist. So when you take a look at what those definitions are, they say if for each epsilon bigger than 0 there exists a delta such that if xy is in the domain of the function and xy is no more than delta away from AB, then f of x minus L is less than epsilon. So they have to do an intersection of that little delta circle, delta disk around the point AB and the domain of the function. Once you're in there, then your function values work. Right? So there's a bit of terminology there that we just want to make sure that everybody has. It's not a difficult concept. It's just that we're using words that we don't use very often. Interior points, exterior points, boundary points, open sets, closed sets. Right? Definitely there's a limit here. Right? This is half of a sphere. This is the top half of a sphere. And as I approach that point 2, 0, they're coming down to the equator of that sphere, which is sitting on the xy plane. So the z value there is 0. And I would expect that this limit is equal to 0. And it is. Right? But it's not in the strict sense of the limit because you can't approach it from every direction. You can only approach it from within the domain of that function. So there you go.